So what we are doing here is figuring out a deterministic two-approx algorithm for minimum vertex cover. And the algorithm is as follows. So given graph G with edges E and vertex V, we pick E from pick an edge, okay, where E, U, V, okay, then we include include both of these vertices into the pick nodes for minimum vertex cover. Then we remove from E all edges with U or V. Then we will repeat. Okay, so basically this algorithm is gonna randomly pick an edge. So say I pick this edge first, then you add both of these nodes into the minimum vertex cover, and thereby removing all these edges. Okay, then now with all this remaining, let's say it picks this edge, then now it's gonna take these two vertices, and this will remove this, and with the remaining one you add these two vertices, and now here we got all six vertices picked. Okay, so we are not claiming that this is the best algorithm. We are claiming that this is just a two-approx algorithm, and we are going to prove it. So what does two-approx mean? Two-approx means that the answer given by the algorithm, okay, answer given by the algorithm will be less than 2 times the size of the optimum answer. Okay, and this is the proof. First, we consider matchings. Okay, so matchings is a set of edges where the vertices are only connected with one edge each. So for a set of graph, we can have many different set of matching. So let's just pick one set of matching here. So let's say we pick this, this, and this. Okay, we can see that we can't pick all these because picking all these will make one of the vertex have more than one edge. So so what we can see is that minimally, okay, so the number of edges that's covered in the matching M, okay, is gonna be less than the size of M is gonna be less than the size of E, right? The number of all the edges in the graph, and which means that not all of the edges will be covered. So for the minimum vertex cover, we need at least one of these nodes to be in the minimum vertex cover in order to cover this edge. So we can see that the size of the minimum vertex cover, so the optimal, is at least the size of the matching, because there are some edges that are not yet covered. So this is one of the key findings that we will use here. Okay. And why is this helpful? Because in here, what we are basically doing is, so our algorithm, which returns this A, okay, is gonna be, so every time we pick a matching, right? And this is gonna be just be the a certain matching times 2, correct? And we have seen that this is the case, so we are going to say that this is less than or correct times 2, and therefore here we have that this particular algorithm is basically gonna give a minimum vertex cover of size of less than twice the optimal size, therefore it's a 2 approx.